In this video, we're going to look at how we'd solve task 8 question 8, but this time using the free LogicGate simulator website. So here on the screen, you can see task 8 from the course notes. It's on page 17 of the notes. I'm going to be switching to the LogicGate simulator. So if you want to follow along with the task, you may want to open that up separately now. So here we have LogicGate Simulator. The link to this you'll find on the course Moodle page, but of course you can see it in the address bar on the website just now. So in this task, we're asked to build a vending machine that dispenses hot drinks. And in the task, we have 6 inputs and 4 outputs. Outputs are very similar to Yenka. We use an LED, and in this case, rather than dragging, we click to select an LED and we click on the screen to place. So I'm going to place 1, 2, 3, 4 outputs to represent coffee, milk, sugar, and tea, which are the outputs of our machine. And I'm going to set up 6 inputs as well. Now, because of the way LogicGate Simulator works, because we want to switch between ones and zeros, rather than using positive and zero inputs, we'll generally use the positive inputs, and then we'll put a switch between them and the circuit in order to allow us to switch them on and off. And just like in Yenka, we have the option of a switch, which is like the latching switch in Yenka, and a push button switch as well. And here we're just going to use switches. So I'm going to put 6 of these also. I'll take a moment just to move these around and connect them up to the positive sources, because we want this to be just like this. So each of these is effectively giving us the option of switching a 1 on. So because the switch is open, we'll be set to 0 coming out the right hand side of the switches, but we can in fact make them 1s by toggling them, and we'll use an example of that. In the question, you'll see that there's 4 OR gates, 2 4-input OR gates, a 3-input OR gate, and a 2-input OR gate. Now, without the benefits of a full software package like Yenka, we don't have all of these options here. But if we think about it carefully, we can use 5-input OR gates for anything up to 5. And the reason for this is even if some of the inputs are not connected, as long as we still have at least 1 positive input, a 1 going in the left-hand side, the empty inputs don't actually make a difference to the functioning of the gate. So when you have to use a 3 or 4 or 5 input OR gate in LogicGate Simulator, then use the 5-input OR gate and it won't make any difference. Because the final gate is a 2-input OR gate, well, we have a 2-input OR gate we can use, and we insert that here. Now, just like in the Yenka example, I'm going to put labels on for all of our inputs and outputs. I'll do that as quickly as possible. Again, slightly different to how things work in LogicGate Simulator. In fact, somewhat more intuitive. The label will appear where we click, and we don't have to resize boxes. So some advantages, some disadvantages from using this particular method of doing things, but we'll do this as quickly as possible. This is far from the interesting part of building logic circuits. Notice in this task that every input on the left-hand side is a description of the drink, but on the right-hand side we have it broken down into the components that make up those drinks, and details like that are important in the questions that we'll be looking at in TMAs. So we've got a lot of inputs now. I'll quickly get our outputs as well. The possible outputs are coffee, milk, sugar, and tea. So now we have all labels, all inputs and outputs, and all gates from the question. What remains is to connect things up. And we've got to be a little bit careful with this, but it's not too tricky if we are systematic in looking at a diagram. The easy bit to start with is the right hand side. Each of the OR gates is directly connected to one of the outputs, and here using this website we select the wire tool at the bottom and click on the circle at the left hand side of the gate and join that to the circle at the right hand side of the gate and join it to the circle at the left hand side of the indicator. So 4 of these are connected. Now on the left hand side of the gate we're going to connect our input switches to any gate that's connected to an output that has a component that we need in our drink. So black coffee has to be connected up here so that coffee will come out. White coffee needs to be connected to coffee, but it also needs to be connected to milk. And you might find this sort of easier in some ways than Yenka, and we do have the advantage that we're not limited by doing everything at right angles. The downside is sometimes it can be harder to see exactly what's what, and it's worth resizing, moving things about, and generally rearranging in order to make sure that you can see things clearly. But I think the way we've laid things out here will be fine. Sweet black coffee is going to be a combination of coffee, sugar, and sweet white coffee is going to be coffee, milk, and sugar. I'm just making sure I don't join any of our wires together because the same challenge exists in Yenka. I want to avoid it here. Tea in this problem is designated as tea with milk in it. So we have milk and we have tea. And lastly, sweet tea is going to be tea with milk and sugar. So tea, sugar, and milk. So this looks good. Of course, we'll test it out. And this should be the circuit built. This is the first part of the question. Now, if we remember, of course, we need to press the play button here to make simulator run. And straight away, all of the positive inputs go to red, but nothing else does because none of our switches are on, which is what we'd expect here. And we'll get to testing some of these in a second, but let's look back at the question. Explain what happens when a button is pressed. Do this for at least 2 selections, and it gives the example of when I press the white coffee button, the coffee output and milk output will both switch on. And of course, that is what happens here. Those 2 LEDs go red. In this question, you've been asked to do this for 2 more. So you say when I press the black coffee button, the coffee output will go on, and you do it for something else as well. And this is similar to what we'll be doing in the TMA with the testing question. The TMA will be given a set of criteria about all the things that our circuit is meant to do, and you're going to describe how you'd test it by which buttons you'd press, how you'd press them, and what you'd expect to happen. And then you record next to it what did happen, and in the event it was different, well, you might draw some conclusions for that, but certainly you make clear that it was different than what was expected. So that's definitely part of the TMA, and you can do it exhaustively here. You could describe what you think each button is going to do based on its description, and then what it does do. And in this particular circuit, each button does what it's meant to. We know we've built it that way, but we could have added some additional criteria or additional inputs, and we'd have to test as well. And the TMA will be a bit like that. Part B is explain what happens if 2 buttons are pressed at the same time. Now back at the start, I said we had the option of the button or the switch, the push button or the latching switch. And we've got the latching switch, and if we switch 2 things, if I pick tea and black coffee, you can see we get a mixture of coffee, milk and tea, which is not desirable. And so that's what would happen in this particular circuit. If I had put in buttons instead of switches, I would only be able to press one at a time. And so my answer here would be, I can't press 2 buttons at once. It's not possible because of the way the circuit's been designed. And so it wouldn't be available. But if you've got it with switches like this, then for the TMA style question about how we could improve a circuit when changing the nature of switches or adding some additional gates to prevent 2 options being dispensed at the same time would be a good example of an improvement you could suggest to a circuit. Now, as I said, this is the Logic Gate Simulator website version of this task. There's also a video that's been made for Yenka, so if you're going to be using Yenka for any of the software tasks, you can watch that video instead. You'll find it in the same place that you found this one.